All right, section 5.3. We're going to talk about inverse functions and inverse relations here. So let's start by talking about, well, first of all, I think this is a concept that you have maybe explored briefly in Algebra 1, but we're just going to sort of teach it from scratch here. So an inverse relation is a set of ordered pairs that is obtained by exchanging the coordinates of each ordered pair. So basically you take the x's and y's and you exchange them. Okay, so a relation, remember, is just a group of points that you have a domain. Well, you don't even need to call it a domain, I suppose, but you have independent values and dependent values, x's and y's essentially. And to find the inverse of that relation, you just take and you exchange all of the x's and y's. So to find the inverse relation b here, b would be equal to just taking this relation, and each point you're going to change the order of the coordinate. So that would change to 5, 1. This one would change to 6, 2. And then this one would change to 7, negative 3. You're not changing signs on anything. You're just simply changing the order of the points. Okay, so that gives you the inverse. Now, what this has the, well, actually, before I say that, let's go to number 2, and we'll look at what happens graphically here. So to find the inverse of this relation, I'm just going to take, again, and change the order of the points. So if this is at 2, 5, point B is at 2, 5 here, right? I'm going to change the order of the points and plot it. So then I'm going to plot 5, 2. So I'm going to go over 1, 2, 3, 4, 5, and up 2. So there's where that point would land. I'll take C here. C is at 1, 2, 3, 4, comma, negative 1. And I'm going to plot it at negative 1, comma, 4. So that would be the inverse of that point, C. And then, so I guess let's label these B prime, C prime, just with little ones here, or C1 or whatever you want to call it. But, and then A is at 1, negative 2. So then we'll plot this at negative 2, comma 1. So that's A prime right there. And then we're going to make a triangle. Okay, so you can see, so then we're supposed to describe the resulting graph. You can see there's some sort of relationship between the two. They're the same, like they look like they have the same area, for instance. And it turns out that this triangle is just reflected over the line y equals x. So this is the line y equals x. So what we have in describing their graph is just a reflection over y equals x. And it turns out that that's exactly what happens when you exchange all of the x and y points, is you get a reflection over the line y equals x, right? So let's go down here and let's set aside what we just learned about individual points, and let's talk about inverse functions, okay? So instead of having just a discrete set of points, we call it, we can give you an entire function, something like f of x equals 2x minus 5, and we can find the inverse of that function, as opposed to just a relation of points, all right? The inverse of a function is denoted by, well, inverse of a function f of x is denoted by this notation, f, in fact, I'm going to write it off the blank. You might be able to fit it in there, but I just want to write it big. So f, and it looks like it's raised to the negative 1, but that's read as f inverse of x, okay? The inverse of f of x, or f inverse of x. Either one of those is fine. The steps for finding the inverse of a function are you exchange x and y, you solve for y, the new y, and then write it in an inverse notation. And I think these steps are easiest to see if you actually do an example here. So let's do that. Find the inverse of the function, then graph the function and its inverse. Okay, so the first thing I'm going to do, if it's given in function notation, is I'm going to write this as y equals 2x minus 5, because my first step is to exchange x and y. All right, so let's change x and y around. Switch to black here. So I have x equals 2y minus 5. So that's step 1. And then I'm going to solve for the new y. So I'm going to add 5 to both sides. So I get x plus 5 is equal to 2y. And I'm going to divide both sides by 2. Now, you can leave it like this, but probably the book's answers and it will probably show up like this on the quiz too, are going to divide both of these things by 2. So if I take x over 2, that's the same as 1/2 x. And then 5 divided by 2 is just 5 over 2. Okay, and so that's what the inverse looks like. Last step though, step 3, is we got to write this in inverse notation. So finally, we'll just write the inverse of f of x is equal to 1/2 x plus 5 over 2. Now, we do this last step because you can't define y in 2 places in the same problem. So if I say y is equal to 2x minus 5, and then later on I say y is equal to this, that can't be true, at least in the context of the specific problem and what we're doing here. They both be equal to 2 things, but we know they're not. We're just using this as a tool, I guess, to figure out what the inverse is. Okay, so let's graph the inverse here. Y-intercept at 5 over 2, that's 2.5. So we'll go up 1, 2.5. Slope is 1/2, so we'll go up 1 and over 2. Up 1 and over 2. And then we'll graph that line. And you can see it ends up being a reflection of the original. Here's the original here. It ends up being a reflection over the line y equals x. So even if it's a function, it's still going to be a reflection over the line y equals x, all right? Okay, last step here, or last problem on this page, problems. Find the inverse of the function, then graph the function and its inverse. Okay, so let's start by writing this in y equals notation. We're going to exchange x and y, so I get x equals y squared plus 1. Now I'm going to solve for the new y. So I subtract 1 from both sides. I get x minus 1 equals y squared. Now I'm going to have to square root to undo, to take the inverse of a square actually. And it's a variable, so I need to do plus or minus. So what I get here is y equals plus or minus the square root of x minus 1. Now what this is positive square root of x minus 1 and negative square root of x minus 1. You can take and graph these in Desmos if you want. I'm just going to show you what the graph looks like. So if I plug in 0, I'm going to get -1, so that won't work. But if I plug in 1, I will get 0. 1 minus 1 is 0. So I get 1, 0 as a point. If I plug in 2, I get 2 minus 1. Square root of 1 would be 1. So I get 2 comma 1. And same thing on the negative side. So basically I get this curve like this. And then if I take the negative of it, I'll get the negative like that. And you can see that this can be graphed, but it's not a function. It fails the vertical line test. Okay, so this we can find the inverse of the function, but it is in what we call an inverse relation. It's not actually a function. The inverse is not actually a function. We could have predicted that, all right? And here's how. If we had looked at this graph and thought about what the reflection over the line y equals x would be, we would see we could kind of use reasoning, spatial reasoning, to figure out that, oh, that's going to be like a sideways parabola. The check we can do, the name for it, is called the horizontal line test. So we can do the horizontal line test ahead of time, and we can see that, oh, well, if a horizontal line will cross the graph at 2 points, or more than 1 point, then the inverse will fail the vertical line test. So this is the important takeaway here for the horizontal line test. The horizontal line test, in simple words, says if your given function fails the horizontal line test, then the inverse will fail the vertical line test, therefore won't be a function. Okay, so you can see like this curve here is fine. It passes the horizontal line test. So when you take the inverse of it and you reflect it over the line, y equals x, it will still be a function. Okay, so that's about 75% of section 3. Let's wrap it up here on the back page of the note sheet, verifying inverses. Okay, so there's this interesting thing that happens if you are given 2 functions and you're trying to figure out if they're inverses. If they are inverses, then when you compose them, when you find f of g and when you find g of f, both of those things will simplify to be just x. All right, so let's check that out. So I want to figure out whether f and g are inverses or not. Here's the process. I'm going to take and find f of g of x. Remember, that's f of g of x. So that means you're going to plug g of x in for f. And so when I do that, I'm going to take 1/3 x minus 3 and plug it in here for x. So I'll get this 3 times 1/3 x minus 3 plus 9. And then we'll simplify. So distribute the 3. I get x minus 9 plus 9. And negative 9 plus 9 is 0, so I just get x. Okay, that's good news. Now, so far it implies that those are going to be inverses. Let's check the other way, g of f of x. So g of f of x, which is just g of f of x, like that. I'll take f of x and plug it in for g. So I'll take 3x plus 9 and I'll plug it in here for x. So when I do that, I will get 1/3 times 3x plus 9 minus 3. And then we'll simplify. So I get 1/3 times 3, that's x. 1/3 times 9, that's plus, let's see, 1/3 of 9 is 3, so plus 3 minus 3. 3 minus 3 is 0, so I get x. So these ones are inverses. Yes, inverses. All right, let's check the next one. Determine whether f and g are inverses. So let's go find f of g of x. I'll just skip right to this notation. F of g of x. So that's going to be 4. I'm going to take g and plug that in here for x. So I get 4 times 2 square root of x squared. And I'm going to simplify that. And so I will get 4 times 2 squared is 4. Square root of x squared is just x. So I end up with 16x. That is not x. It's 16x. So therefore, these are not inverses. So no, not inverses. Right? And that wraps up section 3. And the last section of the group before we take the quiz.